Hello, I'm Bemmygail, and I'm the instructor of data communication and networking in a college. I'm also the proud owner of an animation studio. So, in today's presentation, I'll be walking you through my final project for MMS 145 Network Design for a Multimedia Lab. As both an instructor, an educator, a business owner, I understand the importance of having a reliable and efficient and scalable network. So in this proposal, I'll share how we can upgrade our multimedia labs infrastructure to support modern learning and collaboration. So let's dive in and explore the exciting possibilities that this new design can offer. These are the key challenges in our network lab and lab. So there are non-functional computers, outdated multimedia tools, no centralized network setup, disorganized cabling. And this is the current setup of our network lab. So, welcome to our network laboratory or NLab, our space for exploring the fascinating world of data communication and networking. But as you can see, our lab faces significant challenges that hinder its full potential. We have about 50 computers here, yet most are non-functional, and the ones that work struggle to keep up with modern multimedia tasks. Network slots line the side walls of the lab, providing internet access to each station, but we lack an efficient central network design. The TV screens remain underutilized, and the messy cable creates not only a visual distraction but also maintenance headaches. This redesign proposal will address these issues head-on by implementing a robust and scalable network design. We'll transform this lab into a state-of-the-art multimedia workspace. Together, let's reimagine the NLab as a hub for innovation and collaboration and learning. Let's explore the proposed network topology for our redesigned NLab. To ensure the lab functions efficiently, we'll implement a star topology which connects all devices to a central network switch. At the top of this setup, the router serves as the gateway, linking our lab to the campus network. This ensures internet connectivity and access to shared resources while creating a distinct subnet for the classroom. From the router, a single cable connects to the switch, which acts as the backbone of the lab's internal network. The switch distributes network connections to every computer in the lab, including the instructor's workstation. This design allows me as the instructor to have centralized control over the network, enabling me to monitor student activity, the internet speed, management, manage the internet access, and even use virtual machines for practical demonstrations. Now let's talk about why this setup works so well. Number one, scalability. If we need to add more devices in the future, such as additional student computers or multimedia tools, it's as simple as plugging them into the switch. This ensures flexibility. Flexibility ensures the lab can grow with our needs. Number two, reliability. One of the strengths of star topology is that each device is independently connected to the switch. If a cable or a single device fails, the rest of the network continues to function without interruption. Next is performance. With dedicated lines running from the switch to each computer, we minimize interference and ensure consistent speeds. This is crucial for tasks like video editing, simulations, or streaming, which require higher bandwidth and low latency. To visualize this setup further, here is a packet tracer simulation image. It shows the router connected to the campus network, the switch at the center, and each device linked via Ethernet cables. This diagram helps us see how data flows efficiently and reliably across the network. Selecting the right transmission media is one of the most crucial decisions in designing our multimedia-ready network. For our lab, I propose a wired Ethernet setup to connect all devices using Category 5 or Category 6 Ethernet cables, which are commonly used for network connections in many environments. Let's compare the two primary options, Ethernet and Wi-Fi. Ethernet cables like the ones shown here offer exceptional speed and reliability. Category 5 Ethernet in particular supports higher data transfer speeds and can handle bandwidth-intensive tasks such as video streaming, virtual simulations, and large file transfers. A wired connection minimizes packet loss and interference, ensuring seamless performance. On the other hand, Wi-Fi, as seen here, with a laptop connected wirelessly, is convenient. It allows devices to connect without being tethered by cables, offering mobility. However, this convenience comes with limitations. Wi-Fi signals can be disrupted by walls, other devices, and even weather conditions. Additionally, wireless networks tend to struggle with consistent speeds, especially when multiple high bandwidth applications are being used simultaneously. Here's why Ethernet is the better choice for our network lab. Speed. Number one, with Category 6 Ethernet, we achieve much higher data transfer rates compared to Wi-Fi, ensuring smooth multimedia playback and real-time collaboration. Reliability. A wired connection eliminates the risk of dropped signals and fluctuating speeds, making it more dependable for high-stakes tasks like live editing or streaming. Latency. Ethernet's low latency is critical in a lab environment where simulations and multimedia processing demand instant response times. To illustrate how data travels through these two mediums, in an Ethernet setup, data moves directly from the switch to each computer over a dedicated line, minimizing congestion. In a Wi-Fi network, all devices share the same bandwidth, leading to potential slowdowns as more users connect. While Wi-Fi might seem appealing for its ease of use, our lab's requirements make Ethernet the most optimal choice. It provides the stability and performance needed to support our multimedia-intensive tasks efficiently and without interruption. To create an efficient multimedia lab, we need to address both the strengths and limitations of our current hardware setup while introducing significant upgrades to meet the demands of modern IT education. Our lab currently operates with a mix of PCs, primarily HP and Asus, that are often disassembled and reassembled due to training and maintenance or troubleshooting needs. While functional, this setup leads to inconsistent performance. The Samsung TV screen serves as the primary display for lessons and film showing or film screening, but its built-in speakers are insufficient for high-quality audio experiences, especially when showcasing IT-related movies or instructional videos. For the proposed upgrade, we'll start by ensuring that all PCs are fully functional and standardized for consistent performance. Next, we'll enhance the lab's audiovisual capabilities by adding a Sony speaker. Sony is renowned for its exceptional audio and video quality, making it an ideal choice for a multimedia lab. The addition of speaker setup will deliver immersive experiences during film screenings, video tutorials, and collaborative projects. To optimize network operations, we'll introduce a high-capacity switch to interconnect all devices. The instructor PC will serve as the control hub, equipped with dual monitors for multitasking, lesson demonstrations, and monitoring student activities. This setup will also enable seamless HDMI connections to the TV for large screen presentations. By incorporating these hardware upgrades, the lab will transform into a cohesive and powerful multimedia environment that enhances both teaching and learning. With reliable PCs, superior audio visual quality, and a robust network infrastructure, students will have the tools they need to excel in their studies and collaborate effectively on IT projects. Effective bandwidth management ensures our lab operates smoothly, especially during the data-heavy tasks like virtual simulations, video streaming, or file sharing. Here, we've used Packet Tracer to simulate the lab's basic network structure. As you can see, the router acts as the central node, distributing data to a switch, which then connects to 5 sample PCs. We send test messages from one PC to another and a PC to the router. The simulation confirms successful communication, demonstrating the reliability of this setup and its ability to handle data transmission without delays or bottlenecks. This foundational setup provides a scalable framework for managing bandwidth as the network grows. To manage bandwidth effectively, we need to understand how various activities utilize network resources. The graph represented here illustrates typical bandwidth usage for common tasks such as video streaming, large file downloads, and general browsing, while the bar chart provides a clear comparison of the bandwidth consumed by each activity. For instance, streaming educational videos or conducting virtual simulations require significantly more bandwidth than browsing or file sharing. By prioritizing high demand activities during peak times, the network can maintain consistent performance. This proactive bandwidth allocation ensures that all users, whether streaming, browsing, or collaborating on projects, experience a seamless connection. By implementing such measures, our multimedia lab will support real-time collaboration and multimedia learning without bottlenecks, fostering an environment conducive to productivity and innovation. In our proposed upgrade, the cost breakdown focuses on key components needed to enhance the multimedia experience in our lab. While the initial investment may seem significant, these upgrades are necessary to ensure the lab's network can handle modern multimedia tasks efficiently. The total cost for these upgrades is 27,500, which includes a new switch, router, speakers, and LAN cables. We're reusing existing components like the TVs and PCs, which helps minimize expenses. For the audio setup, we are proposing Sony speakers to improve sound quality, which is essential for video-based learning. In terms of networking, the new router and switch will provide better performance and reliability, ensuring that multimedia tasks run smoothly across all devices. To reduce costs, we've sourced budget-friendly alternatives where possible. The LAN cables will be standard cables instead of fiber optics, and we'll use a more affordable router option. These upgrades will provide long-term benefits, including improved student engagement and better overall network performance, making it a worthwhile investment. Network security threats are becoming more sophisticated. Here we see a hacker gaining unauthorized access, potentially compromising sensitive data. Network security threats are becoming more sophisticated. Hackers often exploit weak spots in the network, such as unprotected devices or poor security practices, to gain access. This highlights the importance of securing our systems against unauthorized users. Once a hacker is caught, the consequences can be severe: legal action, financial penalties, and damaged reputations. This video emphasizes the need for strong access controls like multi-factor authentication and regular system monitoring to stop intruders before they can cause harm. On the other hand, businesses and organizations rely heavily on secure networks for smooth operations. Effective communication and collaboration are only possible if the network remains secure and reliable. In this scenario, employees freely discuss projects, relying on their network's integrity to maintain confidentiality and privacy. It's vital that we safeguard our network from insider threats as well as external attacks. To protect the lab's network, we must use robust security measures like firewalls, encryption, and regular software updates. Regular maintenance ensures that all devices remain secure and functional, preventing attacks and system failures. With proper safeguards in place, we can confidently create a safe and secure learning environment. This is the type of learning environment that we aim to create: a modern, high-tech lab where students engage in real-world simulations, collaborate on projects, and access multimedia resources. By upgrading our network infrastructure, we can ensure that these activities are supported seamlessly without disruptions. A well-designed lab like this fosters creativity, collaboration, and hands-on learning, equipping students with the skills they need for the future. Here we see students and teachers using advanced technology for interactive learning. The proposed network will allow students to engage in live simulations, streaming educational content, and working on group projects with ease. These activities require high bandwidth capabilities, which is why our design focuses on supporting such needs, ensuring fast, reliable access to all learning resources. Learning is not just about technology, it's about the people who use it. These are the facts of future innovators, equipped with the right tools to succeed in a tech-driven world. With the proposed network upgrade, we'll provide a platform for both individual growth and collaborative success. By embracing this new design, we're not only improving the lab's infrastructure but also empowering students to become the next generation of tech leaders. Thank you so much for listening.